Hi there, this is Andrew Brody with Yokogawa, and today I'd like to talk to you about an interesting combination of products we have. The first product that you're seeing up on the screen here is Fast Tools, and Fast Tools is Yokogawa's supervisory control and data acquisition package, or SCADA package. It's used for creating operator interfaces that can be used to aggregate all types of different instruments, stuff like programmable logic controllers, PLCs, RTUs, remote telemetry units, data acquisition systems like our DAC stations or MW100 DAC Master, or single loop controllers like our UT Advance, all the way up to our big distributed control system, something like Centum DCS, or our safety system ProSafe. Just about any piece of hardware out there can be integrated, and the data can be combined into the Fast Tool system, and it can do trends, it can display data, it can do all the typical things that you'd expect for operator interface software like this. So one of the things that I'm going to demonstrate here today is the unique capability of doing data backfill on a network disconnection or a PC outage. So normally when you've got SCADA software like this and you're out there pulling data from something like a PLC or an RTU, in this case we're talking Stardom, it can be an RTU, it can be a process automation controller, it can do just about any type of control you can imagine. Best way to think of Stardom is if you combine something like a PLC with a data acquisition system into one set of hardware, that's what you get. So normally when you're pulling a PLC and you miss a pull, there's no real capability to ever get that pull back. So that item data for that particular call out to the PLC would be forever missed if this computer that was doing the data logging is down, or if the network between the PLC and the SCADA system were to be down. But with Stardom, since it has that kind of data acquisition type capability and control type capability, it can actually be set up to buffer so that on missed communications, the SCADA system can go and backfill what's been missing. So what we're seeing now is we're seeing a sine wave that's being generated on the controller that Fast Tools here is constantly kind of pulling, saying, give me the data, give me the data. Every second it's going out, give me the data, and it's building up this trend. So I'm going to go here and simulate a network disconnection. So I've gone ahead and pulled the network cable on the Stardom unit. And what we're going to see here is essentially it's just going to hold its last value. So nothing's happening, and we can even see down here, if we take a look at communications for your Stardom, you can see it's in alarm. Essentially the communications off to that unit is suspect, it's got an issue, and we're just holding the last value that came in. If I go and click up here, we can see normal, 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 offline. So we can see that the controller is definitely offline. So what's been happening in the background is the controller is buffering all the data locally. So upon a connection, it can go ahead and backfill the data. So I'm going to go ahead and reconnect the controller. So I just popped back in the network cable into the controller. And after a couple seconds, we should see, oh, the communications is good. And in the background, it went ahead, went into that buffer, and got all the samples that were missing. So we can kind of see that even though the network was out, it was great for this combination. We didn't miss anything. We've got the trend exactly like we needed it. So you're not going to see something like that typically between a SCADA package and a PLC when it's doing real-time polling, but we can do that. So let's kind of take a look at technically some of the things you got to do to set that up. Well, the first thing you got to do is under Fast Tools, under its engineering module, and this is kind of where you set up all its points and communications and events and stuff like that. You actually got to go set up your equipment so that you're communicating with the Stardom unit, and then you've got to make sure that you set up a point. So these are the points that you're going to be pulling in from the Stardom unit. So in this case, we can kind of see here's the equipment and here's the point. There's the particular value we're bringing straight out of it, and I'll show you that later when we take a look at the Stardom unit. The other thing we have to do after your point is set up inside of Fast Tools is you got to go ahead and add that point in to this historian area here. And under Event, you go ahead and put in an item here, and the item here is called Demo Buffer Sign. So there it is. It's that point that we were looking up at above. See? Item, Demo, Buffer Sign. And there it is, and there's an event. And then kind of store on, value change, status. That's just some of the things that we did. So once that's done, we're good. And then, if you're doing it for the first time, go down here and hit Apply. We've got it in our history. The only other thing you'd need to do is actually build a page, drop a trend object on it, and choose to trend that demo buffer sign value. On the Stardom side, let's go ahead and take a look at what you need to do. So we actually have a library that makes this possible, and we can kind of share that with you if you don't already have it, called FT Buffer. So we go ahead and we load that into Logic Designer, which is our programming software. FT Buffer contains all these function blocks. And the first thing we need to do is we need to drop the FT handling function block into the main program, and we need that to scan it at least once a second. I've got this guy setting up to scan every 100 milliseconds. Down here is kind of how fast you can say it's scanning. So we've gone ahead and put the main program under task 0 at cyclic, so we got that there. And then the other thing is I just created a little buffering program here. So here's where I'm generating that sign value. So there it is, sign. So main.sign, remember that was kind of the point that we were grabbing from the controller. And then I'm using this FT time real, and the only thing it has here is EN, which means kind of enable. And the inputs to it are the values, so sign in this case is the input, the interval at which you want to record the buffer, which we've just set to 1. And then the rest is pretty much a default, whether you enable it or not is buffering. But we've also got other function blocks here. So this one is just a time-based buffer. We can also do it based on a difference. We can also do it based on a deadband. So these are all the types of ways that you could use to feed your buffer. Outside the buffer, we've got some variables that need to exist, and these are all these FT variables that we're talking about. I can give somebody this project if they're interested as kind of a jump start. I can even give you the Fast Tools stuff if you need that as a jump start in creating some of this or using it as a learning exercise. But there's a couple variables in here of interest. It's the FT copy max set to 10. That's essentially how many chunks of data Fast Tools can grab to repair the trend. So for the backfill, it'll grab 10 at a time. So it'll need to make multiple calls if it's missing 10 or more samples. But it's allowed to grab 10 every call until it kind of repairs the missing data. And then down here is the max samples. So this is how many items I can actually buffer. And so in this case, it's 20,000, but I believe that it can go as high as something like 32,000. Whatever the kind of IEC programming limit is for an integer. I think it's some 32,000 style number. You can go that high. All right, and then the rest are pretty much just used within the program, but you kind of need them all to function properly. And like I said, I can kind of give you this as a jump start on it. But that's kind of what your Logic Designer side looks like. And so you can buffer as many points as you need. So if you got critical points that you just can't afford to lose, then make sure you kind of hit them with this buffer side. So this is Andrew Brody with Yokogawa. I hope you've enjoyed this quick demonstration of data backfill using Fast Tools, our SCADA package, and Stardom, our remote telemetry unit and process automation controller. take care and have a great day.